Hi everyone, welcome to my YouTube channel. Today we will be talking about memory mapping, okay? And whether you are prepping for exams or just a curious mind, by the end of this video you should know what memory mapping is, the types of memory mapping, why we need memory mapping. It's a very crucial topic in computer architecture, so let's dive right into it. So we all know what the CPU basically does. It processes data into meaningful information, right? Then to do that, the CPU first needs to locate the data in order to process it. So to access the data, it first search for it in the cache memory. Memory mapping defines how data from the larger main memory maps into smaller locations in the cache memory. Let's take it as this. The main memory is the library. The cache memory is your desk. You can't bring all the books in the library to your desk to study at once, okay? So how do you determine which books go where on your desk? Because your desk is way smaller and can't take all the books at a go. So that's where memory mapping comes in. There are three types of memory mapping. We have the fully associative, the set associative, and then the direct mapping. So we take the direct mapping and then discuss it. In a direct memory mapped cache memory, each main memory block is linked to a specific memory line in the cache memory. Okay, let's think of it like a classroom where each student is assigned a desk, and no matter what you do, you can't change your sitting position. Okay, you have to maintain your sitting position, you can't change it. One bad side of a direct mapped memory cache is that when two blocks from the main memory are mapped to a single line in the cache memory, they commit something we call a conflict miss. This is when the two blocks keep crisscrossing each other, they keep replacing each other, so you don't really know which one has the data you are looking for. That's what we call a conflict miss. Now let's talk about the second type of memory mapping, which is the fully associative memory mapping. Now in this type of memory mapping, any block from the main memory can map to any line at all in the cache memory. Okay, let's take it like a classroom where every student is allowed to sit wherever he or she wants. Okay, so in this type of memory mapping, any block from the main memory can map to any line at all in the cache memory. They don't need any rules, they don't need any guidance, just pick anyone you want. That's what happens in the fully associative memory mapping. One good thing about the fully associative is that it reduces conflict miss since there are no fixed positions, and this also ends up making the cache memory more flexible. Now let's start the example we talked about earlier, the classroom. Now since in this classroom everyone is allowed to sit anywhere he or she wants, when you come and then someone is sitting at a position you want to sit in, you don't fight the person, you just move to another empty seat. Okay, and in real life this reduces conflicts. For the disadvantage of fully associative memory mapping, now the hardware has to check every single cache line to see if a block is already there. Now this single checking process needs more complex circuitry and then more comparison time. You get it? So that's one bad thing about the fully associative memory mapping. Let's move to the third type of memory mapping, which is the set associative memory mapping. The set associative memory mapping is a compromise between the two ones we talked about earlier, the direct memory mapping and the fully associative memory mapping. This is how it works. The cache memory is divided into sets, okay, and then each set has multiple lines. Now a memory block maps to one set, but within that set it can map to just one line in that set. Let's say we have a four-way set associative, meaning we have 4 lines in every set. So a memory block can pick one line out of the 4 in that set, move to another set, pick one line from that set, that 4 line set, move to another set, pick one line. So in that case it's more of like an organized one. Okay, it's very organized in the set associative because you can only pick one line out of the 4. The set associative memory mapping is the best out of the 3 I've mentioned, all the 3 I've mentioned so far, because it has less hardware overhead than the fully associative, and then it has fewer conflict misses than the direct map, and it's also a balanced approach. I've simplified all the differences into a table form so that you can easily understand it. Okay, so for the direct mapping, it has low flexibility, it is very fast, simple hardware complexity. And then for the conflict mix, it's very high because it's directly, you can pick anyone you want. Okay, now for the fully associative, flexibility is very high, the speed is low, hardware complexity is very complex, okay, because it needs to be doing the checks back and forth and all that. And then for the conflict mix, it's very low. Okay, it's very low. Now for the set associative, flexibility is medium, speed is medium, hardware complexity is medium because it doesn't really need to be doing a lot of checks and stuff like that. So hardware complexity, we just need something to do the mapping for us. And then the conflict message is medium. It's lower than the direct map and then higher than the fully associative. That's why I said earlier that it's a compromise between the two. That's memory mapping in a nutshell. We learned how direct memory mapping is simple but restrictive. Fully associative is flexible but expensive due to its hardware complexities. And then set associative is a balance between the two. Remember, it's all about how we organize access to fast memory to boost CPU performance. Thank you for your time. Don't forget to like, subscribe, and then comment below if you need more videos on any topic at all in computer architecture, and I'll get back to you. Thank you. Adios.